Picking up where we left off with the Code Crafters Redis challenge in Zig. So today we're going to implement get and set. We'll also implement a store to store all of this, and look forward to what comes next after that. So let's get started. Okay, so I've got my Code Crafters Redis Zig project up here. So what we can do is go to Code Crafters. And we can see that we need to implement the set and get commands. So here's some information on these commands. You can see Redis CLI set foo bar, Redis CLI get foo returns bar. Makes sense. Information on how the tester executes our program, some information on the output, and some notes. So if you implemented a proper Redis protocol parser in the previous stage, you should be able to reuse it. Yeah, I think ours is close enough. We should be able to reuse it. Just like in the previous stage, the values used for keys and values will be random, so you can't hard code things. Sure. If a key doesn't exist, the get command should return a null bulk string. We won't explicitly test this in the stage, but you need it for the next stage, expiry. Okay, cool. Any notes? No notes on this one? No hints? Cool. Filter by Zig. Interesting. Still no hints. Huh. Okay. Well, let's get to it. So the very first thing I'm going to do is we're going to go ahead and define a store. So I'm going to create a new Zig file called store.zig. Let this boot up. Okay, cool. And we're going to go ahead and import the standard library. Let me make this a little bigger. Okay, I think that should work. So we're going to import the standard library. We're going to import our resp package. So import, and this is local. So we call this parser.zig. Probably should change the name too, but we'll do that maybe later. And then we need to create some form of a public variable for our store. So I'm going to create a public var store. We need to give this a type. The type is a store. I don't know if this is a Zig pattern or not, but we're going to do underscore store for the struct. So it's essentially private. The struct itself is private. We don't necessarily want people creating an instance of the struct. We'll manage that. I'm also not sure what we would call the store. This probably isn't the right pattern. So if you do know the right pattern, let me know in the comments and I will adjust this in a future video. But for now, we can go ahead and just set this to undefined. And then we need to have a function to initialize it. So we'll have something like a init. This will take in an allocator. That'll be a standard mem allocator. And the return type on this is going to be void. We are going to initialize the store variable instead of returning a store struct. And part of this is to essentially have something global in our application that can be accessed by multiple threads. Maybe that's not the best approach. Maybe it is. We could spend a bunch of time debating that. I think for me, the trade-offs of this approach are worth it. So we'll take this approach for now, and we can always adjust things as we get further into the project if we find the need. So let's go ahead and create our store. We're going to have like a store init method here, and it's going to take in an allocator. Underscore store doesn't exist yet, so let's go ahead and define that. So we'll say const store. Oh my goodness, const store is equal to, and it's a struct, and the store is going to have a store itself. This will be something like standard string hash map. We need to give this a comp time type. So this is going to be the value that we're storing in the hash map. So let's do a resp.value, and we can go ahead and set this to undefined. We need a mutex because we are going to do updates from multiple threads. So we're going to make those mutually exclusive with a mutex. So we'll do standard thread mutex. Go ahead and set that to undefined. And then we're going to have an allocator that gets passed in. So we have standard mem allocator. Let's go ahead and define our public function init. This takes in an allocator like we just talked about, and it's going to return a store. So what we can do here is define our local store. I probably should stop calling everything store. I feel like store is all over the place in this file, but hopefully this will be clear whenever we actually kind of get things going. So we have a const store, and that's going to be a standard string hash map resp.value, and then we need to initialize it with an allocator. Whoops. Okay, so we have an allocator here. Don't forget our semicolon. We need to go ahead and initialize our mutex. So I've got a const mutex is equal to standard thread mutex. And then I need to return that store. So we have a store is equal to store, a mutex is equal to mutex, and an allocator is equal to allocator. And the reason we're wrapping this hash map up into a store struct is that we're going to do a couple things that the hash map's not going to do for us out of the box. So one, we're going to acquire a mutex whenever we do reads and writes. So that's not something that the hash map is going to do for us out of the box. So we'll encapsulate that. And then also, we're probably going to need to duplicate some things. So the way that we have things set up currently, everything is working in an arena allocator. So when we parse a request from the Redis CLI, what we're doing is we're storing all of the things that we've parsed in an arena, and then when we finish with that request, we deallocate the arena. This has worked out great, but now that we're actually needing to store values for a lifetime longer than the lifetime of the arena, we need to come up with a way to do that. So I still like the idea of our arena. I think that's very clean. So what we're going to do is set up the ability to duplicate items that are defined in an arena so we can store them longer term. So let's give this a go. So we have our init. We need to define a get, and we're also going to define a set. So let's start with the get. So this is going to get a reference to self. This is going to look really weird because this is a pointer to underscore store. Yeah, I really am not liking that underscore, but we'll continue with it. So we have a key. A key is going to be a string or a slice of const u8s. And we're going to get a resp value back. And from here, let's go ahead and say self mutex lock. We want to go ahead and lock that mutex. We want to defer unlocking it, or else we'll be in a very bad spot if we don't unlock this. We can say self store.get, and then we want to get the value at the key. And then we can just return the value. I think that should be fine. Set's going to be similar. So we're going to say pub fun set self pointer to our store struct. No, pointer to our store struct. Let's try that again. And then we have a key, which is going to be a const u8. And then we have a value, which is going to be a resp.value. One thing to think about too is, do we really need to store the entire resp value, or could we store just a representation of it, maybe the string or the int, or whatever type we're working with under the hood? I think resp.value is going to give us a nice abstraction point, so we'll continue to use that for now. But something we could think about is, do we really need to keep the entire resp value in memory, or could we just keep the data that is relevant for the resp value in memory? Okay, this is going to return an error void. And what we have here is we're going to do self mutex lock, defer self mutex unlock. And then we need to essentially duplicate the key and the value. So let's go ahead and duplicate the key. So we'll say const dup is equal to try self.allocator.dup. This one's nice and easy because duplicating strings is really straightforward. So we have our dupe there. This one's going to be a little trickier though. If we need to duplicate the value, we'll say something like const dup value is equal to try self. No, let's not do self. Let's do, we'll need to build this. So let's do value.dup self.allocator. We'll let the value determine how it should be duplicated. So once we have those two, we can check we want to check if there's an existing value. So we'll do that by storing existing in a self.store.fetch put. I don't know why my IntelliSense is not being very helpful today. We want to fetch put dupe and dupe value. So what fetch put does is it fetches the value in that key if it exists and returns it. And then it puts the value that you've provided. Basically, it puts the value at that key and then returns what was existing if there was anything existing. And we need that because we need to say if existing, we want to get the pair, the key value pair, and we need to free some of these things, right? So we're duplicating the string so we can free pair key. And then we also want to do pair.value.dinit, and then we can pass in self.allocator here. Okay, so we're cleaning some stuff up as we go. We're missing some semicolons. So let's go ahead and add those. What is this? Minus 23. Feel pretty good about that. Let's just take a look at this. Okay, yeah, this seems pretty straightforward. So the key thing here are the get and set methods. So we'll start with those. Let's see what else we've got going on here. We'll need to modify a couple different things. Let's go ahead and start with our parser, our resp.zig. What we're going to do is go somewhere into value. Yeah, like right here, actually. And then let's do pub fun dupe. And then we have self value allocator. And this is going to be a standard mem allocator. What this is going to do is return an error union with a value. And essentially what we're going to do here is take a look at what we're working with and then duplicate it. So I think for our case right now, we can get by with switching on self. And if it's a simple, a string, or an error, what we can do is capture that value and then do something like const data is equal to try allocator.alloc. And we need to allocate U8. And we need the existing string's length of bytes. Then we can do a memcopy. So if you haven't seen this yet, I don't think we've used too many built-in functions using the at symbol during our codecrafter stuff yet. So this is a built-in function. It copies bytes from one region of memory to another. So you can see that dest must be a mutable slice, source must be a slice, a pointer to an array, or a mini item pointer. Dest also can be a pointer to an array or a mutable mini item pointer. It may have any alignment, it may match any element type for both of those. There's some type coercion. There's some information about how this works. And then a key thing is that the two memory regions must not overlap. So in our case, this should be fine because we're just going to mem copy data as our destination. And our source is going to be the existing string. And then we can just go ahead and return a value here. So this will be a string of data. I think that should be good. We actually may need to differentiate between the types here as well. That might be something we pull out here in a minute, but let's just see if this approach works for now. In the case of an array, I don't know if we'll actually need to support arrays, but let's go ahead and figure out what this could look like. It'll probably be the same approach. So we're going to get our data, and we'll do allocator.alloc. We need a type, so this is a value. And then we need something like a.length. We can do another memcopy. This will be data, and then this will be a, the entire array. And then we can return something like array is equal to data. Something like that should be pretty good. We have a couple more types that we need to support. So we have null string, and then we also have integer. And I don't think we need those for this slice of the challenge. So let's just go ahead and return error.notsupported. If we see that error, we'll come back and implement those. Oh, missing a comma. Okay, feels pretty good. Let's go ahead and open commands.zig. Oh, interesting. Recover, please. Found swap file. I think this should be fine. Kind of confused by that. Let's see. It's fine. Let's continue. So let's go ahead and implement git. So our git command is also going to be a struct. It's going to be something that receives multiple values. I guess maybe only one. I'm not sure if the RESP protocol allows us to get multiple. So there's a get right there. Get key. Okay, yeah, it seems like it does not. So so instead of values, let's do value. It's going to be a resp.value. And then what we can do is define a pub fun execute. This is going to be self. It's going to be a pointer to get. And then it's going to get a writer, standard io.any writer. Return type is void, just like all the above. And what we're going to do here is essentially execute our get command. So we know that we have a single value that we're working with. So what we can do is switch on that value, self.value. And then I think we only support strings for the key. That makes sense, right? Because it's ACL category string. Okay. So we essentially want to check and make sure it's a string. If it is a string, we'll capture that string. We'll do something with it. If it's not a string, so if it's an else, let's return error.key not a string. Some error case to return. Okay, so in the case of it being a string, let's go ahead and say const values equal to, we need to get that store. So that's going to be something like store .store.get s. Let's go up here and add our store. Const store is equal to import store. Okay, store dot get. Okay, cool. Yeah, we have IntelliSense now. Great. So we're going to get that key, or else we need to try writer.write. And then we have nil. If the key does not exist, the special value nil is returned. Let's take a look at the Code Crafters challenge because they had something specifically for that. This null bulk string. Okay. So let's just paste that here and run with that for now. We can then return. Formatting. Oh, I see my issue. Okay, feeling better about that. Formatting feels really off here. Not sure if I'm doing something wrong. Line 35, expected semicolon. Okay, I am doing something wrong. The value is not being used. That's not true. We just haven't used it yet. So let's try value.write, and then we'll pass in the writer. Missing a semicolon. Okay, so that gives us a get command. I feel pretty good about that. Okay, let's go ahead and define our set function, const set. This is going to be a struct, and we are going to get the values. This is going to be a slice of value. And I think that's all we need. I was thinking we might want an allocator here, but I don't actually think we need one since the store is taking care of allocating itself. So let's go ahead and create a pub function execute, and this will be a self dot or a reference to set, and then a writer, which is going to be a standard IO any writer. Again, this returns an error union with void. So we can do if self.values.length is not equal to 2. Return error.invalid command. And the reason this is an invalid command is because set requires two values. You have a key and then a value. So we're checking to make sure that we have two values. Otherwise, it's invalid. So we'll go ahead and return an invalid command. Oops. So, okay, we're in our execute. We're checking. We're doing some validation. We're going to go ahead and get the key. So this is going to be self.values0. And then we're going to switch on the key just like before. So we're going to check the key. And if it's a string, we'll capture the string. If it's not a string, return error key not a string. Just like we did before. This time though, we're going to try store.store.set. And then we need a const u8. So that'll be S. And then we need that value, which is going to be self values 1. Looks like we are missing, per the usual, a semicolon there. We have an unused function parameter. Oh, we actually need to write something at the end of all this, don't we? So assuming we don't run into the error case, we have our switch. Let's try... You know what we could do? Instead of just writing directly to the writer, we can leverage our resp value stuff that we've written. So we could do resp value.write, and then we need to give it a value. So we can just say that in the case of it being correct, I think it's a simple string. Is that correct? Set. Okay. Yeah. Okay, cool. It is a simple string, I believe. So what we can do here is... dot simple is equal to okay. And then we need to give it a writer. We've got a writer, so we'll just pass in the one that we have. And yeah, I think that should be pretty good. Okay, so the meat and potatoes of this then becomes the main Zig and wiring it up. Okay, I think I'm going to use this as an opportunity to refactor a little bit too. I kind of like the idea of encapsulating the handler and the request processing into like a server struct. So we're going to create another struct. I think in our case, all we really need is an allocator, standard mem allocator. We can set up an init function. So this will take in an allocator and return a standard mem allocator. And it returns an error union with a server. We can return server here, server. And then we need allocator is equal to allocator. There we go. And then the real reason behind this is taking this handler function and this process request function and moving those up to here. We'll need to change the type here too, though. So this will need to be a self pointer to server. And then it doesn't need an allocator anymore because we have an allocator that we can provide to it. And then the connection. So in our case, let's go ahead and clean this up. So this will be self.allocator. What else do we have? Actually, it looks like that might be it for this function. Really? Self.allocator, arena alloc. Okay, I was expecting to have to do more, but I guess not. And then for process request, I think we're going to do the same change. So our allocator becomes a self, which is a pointer to a server. And then, oh, that's not entirely true because we have the arena allocator that we're passing to process request. So we do still need an allocator. Allocator, standard mem allocator. Okay, this feels maybe a little less clean than I was hoping for. So since we're adding that self to process request for the server, we need to go back to our handler and change this from process request to self.process request. we have our self here. So let's look at this and make sure we don't need to change anything. So we have our request. We're deinitializing it after we are finished with it. We're checking if it's a ping. We're checking if it's an echo. We're now checking if it's a request.isGet. And then we also need to check if it's a set. So in the case of a get, it's actually really straightforward here. It should just be var get equals commands.get. Our value is going to be request.args 0. Yep, that should be good. And then we can return get.execute, and we pass in our writer. Feel pretty good about that. Let's do the same thing for request.isSet. Set is equal to commands.set.values. And then for the case of all of our values, we can just do a request.args. I feel like that should be good. And then what we can do here is return set.execute writer. Okay, actually, it's not much more complicated than get. I was thinking it would be, but it really does not seem that bad. We'll need to clean some stuff up down here. So in our pool spawn, so we have our handler down here. What we can do is change this to, I'm sorry, not self. It should be server.handler. No. Oh, no, it should be. We just need to create the server first. How silly of me. So let's come up here to right after our allocator, and we'll go ahead and define var server is equal to server.init. We're going to give it an allocator. And then this is kind of important. If we can't initialize the server for whatever reason, let's just panic. Go ahead and get that out of the way. So we'll just say unable to initialize server. Defer server.dinit. We'll need to create a dinit method as well. In our case right now, I don't think we have anything to deinitialize, but let's head back up here and go ahead and create that method. So pub fun dinit void to do. Because I don't think we currently have anything that we need to worry about deinitializing. So okay, interesting. On 37, we have an unused function parameter. Process request doesn't use self. Okay, that makes sense. We're not using it anywhere. So let's just set it to an underscore. And then server handler. Okay, this feels pretty good. We're deinitializing. The one thing we haven't done yet is we need to initialize our store, right? So we wrote some code to handle that store. So let's, when do we want to initialize the store? So we initialize the server, we initialize the thread pool, we initialize address listener. Let's do it after the listener. So we can say store.init allocator. And then, we probably need to define a dinit for that store as well. So const store is equal to import store. Let's start there. Go back to the bottom, store init allocator, defer store.dinit. Yeah. Sure. Wait, did we define one? Does that already exist? No, it totally does not. Okay. Pub fun dinit void. Oh, what does this need to do? This probably needs to get all of the keys and values in the store and deinitialize them. you know what? Let's come back to this. Let's go ahead and get something working first, and we can clean up the memory afterwards. I don't. Maybe that sounds really awful to say, but I think we should be really close to having something working. So we'll start there and then work things from there. We'll work from there on things. Oh my gosh, sorry, I've been talking so much today. I'm starting to get tongue tied. Store a init allocator dinit. Okay, I think we should be good here. Oh, our server handlers changed though, right? We're not passing in an allocator anymore to it. We're passing in a server and a connection. Okay, I say we maybe give this a shot. Go ahead and save. Let's do a Zig build and see. Okay, dinit is not a member function. Has no. Okay, so let's clean this up. So source. What are we looking at? Unable to load source. Oh, geez. Let's go to our store and clean some stuff up. Yeah, this isn't called Parser, right? What was this called? Really? resp.zig. So we'll change it to resp.zig like it should be. That should give us a step in the right direction. This function, interesting. Let's give this another build. Oh, okay. So what we're seeing here is an issue with our server. So we have that swap file again. Okay. So we have this dinit function that we are defining as public, but it's not taking in a server. We don't need the server yet because we're not doing anything here, but we might. So let's go ahead and zig build. Server dinit arrow union is ignored. So let's pull up source main.zig again, 72. I need to take care of that. So server dinit, since we're not actually doing anything, it can't return an error yet. So maybe what we do for now is we just go ahead and remove the error union. Don't do this to me. Come on, LSP. Okay, so in our main zig, we have the same issue with our dinit method here being, I'm sorry, this is the store file, but we essentially aren't doing anything. So I'm going to go ahead and remove the error union from now and then see how things are going. No field named handler. Instruct main.server. Okay, let's take a look. Source main.zig. Okay. Interesting. There is a handler right there. What was that error message? I don't know why that is an error that we're running into. Oh, I do know why that's an error that we're running into. Interesting. Okay, so I have a server instance, but I need the server struct. So that server handler is on the struct, not the instance. That's a very interesting dilemma from how we're spawning this, or I guess using this as a more or less a function, not an anonymous function, but just a standalone function that's not immediately being invoked. That's interesting. So that should take care of that one. Let's give that a shot. Okay, And then on store, we're seeing that a member function expected 2 arguments, found 1. So let's crack open source store and let's debug that. So on line 35. Oh, we need to give this a type, don't we? So that'll be like a U8. And then we'll write and quit. Give us another build. All right, we're getting there. We're getting there. Moving right along. So return expected type mem allocator found type of enum literal. Vim source store line 21. Oh my goodness. How silly of me. I just have an extra dot right here. I was not referring to that as a variable. I was referring to it as I guess a enum literal. Let's give this another build. Hey, it actually built this time. So I am going to use the CodeCrafter CLI to run a test. This is kind of nice. I don't think I've mentioned the CodeCrafter CLI yet, but you can essentially use the CLI to avoid committing to the branch that you're on. So if you want to get everything nice and tight into a singular commit, you can use the CodeCrafter CLI to test things without actually committing it to that branch. I think behind the scenes, it is committing it to like a new branch and then uploading that branch and then running the tests on it. So I figured this would be a good step for us to at least start with this and see how things are going. So we'll let this run. Hey, and that actually takes care of it for get and set. Kind of shocked with that, to be honest with you. So yeah, we can CodeCrafter submit this. I'm actually going to go ahead and just commit it all as well. So git add commit get and set. Let this commit. Go ahead and push this up since we have something working. And I did have someone mention on one of my previous videos that they had some syntax improvements for some of the stuff that I was doing and asked if I would make this repo public. Yes, I will. So I will do that shortly after this video. And then we can, address feedback. And I'm still, while I have some Zig knowledge and I would say I'm fairly confident with the basics at this point, or the fundamentals maybe is a better term for that. Some of like the Zig idioms, idiomatic Zig, the design pattern type approach things. Wow, I'm stumbling over my words today. Design pattern type approaches that you might have in Zig or that you commonly see in Zig are still new to me. So I would love to see any feedback that people have on that, whether that's in the YouTube comments or pull requests on repos or whatever. Any of it sounds fantastic. I love learning new things. Okay, cool. So let me pull this up. So we can see that our test passed. We can mark the stage as complete. And then our next stage will be expiry. So we'll write some code to handle expiration shortly after this. Hey, it totally slipped my mind. We didn't end up writing those dinit methods, so I came back and have written them now. So really quick, just circling through this one more time. So main.zig, we still don't have anything to deinitialize in our server, so I'm going to leave that one as empty for now. But we have store.dinit down here, and we actually need to deinitialize that. So if we go take a look at store, I've got this dinit method here. This needs to have an error union now because we're trying to iterate through things. This is on the store struct itself. So I added a dinit method. We're not calling the one on the store struct because we don't have a handle to that. Or I guess we do, but we're calling things through these global functions. So I added a dinit method here that is going to return void, and it's going to try to deinitialize the store like so. So that should take care of it. Sorry, it totally slipped my mind. Got excited that we were wrapping that one up so quickly, and yeah, I just didn't think it through. So let's give this a Zig build, make sure it builds. Of course it doesn't. Error unions ignored. Oh, really straightforward. Main Zig, we need to address that error union, so we can just defer. Try is not allowed. Interesting. So we can't try. So catch, maybe? Let's catch. I don't know what we would want to do if we run into an error while trying to deinitialize. I guess we could just panic and say unable to deinitialize store. Something like that. I probably need to do more research in ways to handle that, or what the appropriate way to handle that is if you were to have an error while freeing memory. Same issue. It looks like store zig on 11. What error union? How's the error union ignored? Oh my goodness, I see what the error is there. I'm referring to store.store DNet. I just need store DNet. That should be our error there. That being said, we probably do need to actually say self.store.dinit here. Release the backing array and invalidate this map. This does not deinitiate the keys, values, or the context. If your keys or values need to be released, ensure. Yeah, I think that probably should be fine. There's empties the map. There's actually a lot. Empty the map and release the backing allocation. This is not free keys or values. I don't know the difference between clear and free and dinit in terms of which I should be using. So we're just going to go with the dinit for now, but we'll see if that changes. Give this a zig build. Expected. Oh, interesting. Store.zig. I don't know why I'm trying this. Iterator.next. And then actually what's really interesting about this is since we're not actually trying, we can't run into an error freeing memory. So, or at least in this case. So that simplifies this quite a bit. We don't need this here. We don't need this here. We can clean that up, come back to main zig. And then in theory, we don't need this catch either. So let's go ahead and remove that. And I think we should be good now. Let's give it a build. I always get way too far ahead of myself. No field named key instruct hash map unmanage entry. Okay, what are we working with then? So let's go to our store. No value named key. Oh, it's key pointer. That's right. And then pair will be pair dot value pointer. Let's give that a shot. Okay, cool. Zig build. And then what we can do again, since we made fairly substantial changes, is we can run codecrafters test. Go ahead and give this one more run. Hopefully everything passes still, but we'll find out in just a moment. Oh, since we had already marked that one as completed, it is actually running the current tests. So I think we want the previous flag. Hang on, let me double check. Codecrafters help test previous. Actually, I don't know if it will run them in. I don't know what the order it will run them in is. So we might not be able to see. Okay, cool, it does. So all of our tests should pass except for the one with expiry, because that is the one that we're going to do in the next video. So hopefully this was helpful. If it was, let me know in the comments below. I will also try to get this repo pushed up and then get it linked so that you can browse the repo as well. But yeah, if you haven't yet, don't forget to subscribe to the channel. I really would appreciate it if you also gave this video a thumbs up. It helps me out way more than you know. And then if you haven't signed up for Code Crafters yet and you still want to do that, I'll have a link in the chat below that will give you a discount should you decide to convert to a paying customer. But they have a free tier, and their free tier has worked for me for a very, very long time until, I stopped using the free tier. But up until that point, it worked really great. So hopefully it works well for you. I'll have a comment in the video with all of that information. Thanks, and have a great day.